From the 22 News Plus studio, this is 22 News in Focus with Patrick Berry.
Hello, everyone, and welcome to this edition of In Focus. I am your host, Patrick Berry. Today, we are talking about the things that you may or may not be seeing in the deep, dark recesses of space. So joining me across the desk today is Kevin Kopchynski. He is the STEM curator at the Springfield Science Museum. Kevin, thank you so very much for joining me. I appreciate you coming in.
Great to be here as always, Patrick.
I love these conversations. Yeah. We started these during my days in Mass Appeal, and I'm so happy to be able to have longer conversations with you.
This is really nice.
There really are. There's a lot happening off planet Earth.
Yes.
You know, Northern Lights happening periodically, coronal mass exodus. Is it coronal mass exodus or coronal mass eruptions?
Ejection.
Ejection. I was wrong all the way around. But those are what cause Northern Lights.
That's right. And it's been pretty active the past couple of nights.
Absolutely.
And possibly even still into tonight.
Very nice. Very nice. Yeah. But they come back periodically, and there's really no way to predict them, is there?
No. The CMEs... Not really. Not in the long term. In the short term, we have a lot of stuff looking at the sun. There's a great website, spaceweather.com.
Okay.
So you can tune into that. You know, they'll let you know what's brewing, so to speak, up there. So you do have a little bit of short-term notice.
Okay. All right.
But, you know, on December 12th, we can't tell you what's going to happen.
Yeah. So is... the reason we're seeing more of these nowadays is just technology has gotten better to not predict them, but tell us what's happening on the sun, and then also just the sun's more active.
So it's definitely partly the sun more active. It goes through these 11-year cycles, and we are, I think, just coming down off of the maximum of one of those cycles. But then again, it's also about the technology. I mean, we have stuff out there now looking at the sun.
Right.
That we didn't have 11 years ago.
Interesting.
So we've got a lot of things looking at the sun. And again, our space weather has been around for a while. But, you know, we've got that too, where we can just get on every day and take a look, you know, and it really mostly focuses on the sun. Every once in a while, its headline will be about something like a comet.
Right.
But most days, its headline is about the sun and what you might see for Northern Lights. So
you made a passing comment, but I want to get some clarification. Okay. What's the difference between a comet and an asteroid?
Yeah. Okay. Well, and that's a big one. You know, it's a big deal because with some of the discussion of this one, an asteroid is a small rocky body.
Okay.
They generally within the what we call the asteroid belt between Mars and Jupiter, but some of them come to the inside. You know, some of them are on the sort of
inside between the asteroid belt and the sun.
And the sun, yeah. Okay. And this one in particular, 2024 YR4 is one of those.
Okay.
So it therefore gets sometimes close to the Earth. But it's a small, rocky body. A comet has formed much further out in the solar system. The comet, and that's an area where it's cold, so that ices can form. Now, you notice I use the plural because not only water, but carbon dioxide, methane, a lot of things that we would experience as gases here on our planet and on this region of the solar system are going to be ice out there. So they're more like blocks of these ices. Okay. And then as they're further out, but sometimes something happens, they kind of get kicked in towards us. And as they come in and get more of the sun's energy, though the gas begins to or the ice, I should say, begins to sublimate. In other words, changing directly to a gas and then puff off of the comet. So you have what's called a coma around the icy body, a dust ball, basically, and then you get the tail.
Okay.
there is a tail of dust and there's a tail of gas.
And that's all comet.
And that's all a comet. And
Okay.
so that's one thing what folks will look for as they look at an object is, okay, do we see this coma? Do we see a tail? And that would say, oh yeah, that's a comet. And then also its trajectory
Okay.
will tell. Is again, the comets come from further out, and once they get a bead on the trajectory, they can figure, oh yeah, that came from way out there.
Okay.
As opposed to something that came from the asteroid belt or something that even just lives, so to speak, in our vicinity.
So comets come from deep space.
They come
asteroids
from,
come from the asteroid belt between Mars and Jupiter.
Pretty much,
but
yeah. Yes.
Could basically be a comet and asteroid could be the same size. Just depends on where they come from.
Yes.
Okay.
Yes, and again, the comets are more of this frozen, icy stuff, whereas an asteroid is more rocky stuff.
Okay. All right.
Yeah.
So, but these things, they're always flying around,
Mhm.
right? I mean, most of them,
Yeah.
stay with, outside our influence or sphere of
Sure,
influence,
yes.
between Jupiter or Mars and the Earth.
Right.
They usually stay outside that, but
Yes.
periodically, asteroids and comets venture towards Earth, right?
Yes. Yeah. Yeah. So, and we're seeing sort of one of each, in the news this year.
Okay.
A lot, and especially right now. YR4 is the asteroid. Now, this one actually orbits closer to the sun than the asteroid belt.
Okay.
So it kind of gets out towards the asteroid belt at its furthest, but at its closest, it's in near us and it crosses the Earth's orbit.
Interesting.
So that makes it of interest.
Right.
Very much,
And then we need to take our first break. But when we
Okay.
come back after this break,
Uh-huh.
we will get more into
Yes.
that particular
Yes, let's do that. Okay.
orbiting object. We'll leave it at that. I'll be right
All
back after
right.
this.
This is 22 News in Focus with Patrick Berry. This is 22 News in Focus with Patrick Berry.
Welcome back, everyone, to this edition of In Focus. Across the desk is Kevin Kopchynski, the STEM curator at the Science Museums in downtown Springfield. We're talking about the amazing things you can see in the sky. And some of the things are actually putting Earth a little bit at risk, Kevin.
So there was a concern about that. As I mentioned, this 2024 YR4 does orbit. It is, it's an Earth crossing orbit, which means it crosses and that means it could, possibly, potentially
impact
the
Earth.
So this one was newly discovered almost a year ago. And when an object is first discovered, you've got to get location, you've got to pinpoint it, and you've got to get a series of location measurements to figure out what its orbit is. And that takes time. I think people don't realize that does take time, especially if the object seems to be coming more right at us.
So the way you explain this, though, it's in orbit.
Yes.
So does that mean it comes around it's cyclical every
Correct.
100 years, 1,000 years, 50,000 years, whatever it might be?
This one is more like around 3-4 years, somewhere around there. So it's going. It's moved out. It's a small thing, so it's moved out beyond the range of Earth telescopes. In February, the Webb telescope has a small window to be able to see it, but then it's gone until 2028.
Okay.
2028, it comes back in close to us again, and we can start looking at it.
So
again.
As of now, in late 2025, it's already gone.
It's
Okay.
gone from it's just too far out. It's
for us
too
to see,
small and too far out.
Okay.
Yeah.
But there is 2028, it comes back again.
Yes.
We'll get a better bead on it,
Yes.
its trajectory.
Yes.
But there have been reports that 4 years later, 2032, it could impact Earth.
So there were reports initially.
Okay.
Again, because it takes time to get that trajectory well enough to and bring down the error bars basically on the measurements. And so initially, it was up to a 4% chance.
Wow.
But then as they got more and more and more position data and narrowed down those error bars, basically by last March, that chance had dropped to virtually zero.
Really?
So, however, it's now looking at the possibility of the moon, that there's a small chance that it could hit the moon. That right now there's an error bar of where it's going to be, and that's away from the Earth, but that error bar kind of surrounds the moon.
Okay, so, I'm trying to get this video to stop. There it is.
Oh, yeah.
Okay, I'm trying to get that to stop.
Sure.
I don't think I can.
So the yellow bar represents the possible places that this asteroid might be, and the moon is kind of like right in the middle of that.
Oof.
So I think the moon now has about at this point, a 4% chance of getting hit. And that's as good as we have. We've lost sight of it now. We can't get any better measurements. Again, in February of 26, Webb has a small window to be able to see it and possibly get a little bit better. But then it's not until 2028.
And then in 2028, you and others in your field will have you'll have more data.
Exactly. There's going to be more data, and probably that error bar that we saw, or that possible range, will probably be narrowed down.
Okay.
And then it'll either be on the moon or not.
Right.
We'll see.
We're cycling through a couple of photos here. I'm going to go back to this one, sort of a top end. Looking down.
Yeah, and see that. And one thing in the detail, so you can see some of those blue specks are all asteroids.
I was going to ask you that. All those blue specks are asteroids.
All those blue specks are asteroids. And if you look, there are some of those blue specks that are near our orbit, or even within our orbit.
Right.
Okay. The dense cloud of it, that's out beyond Mars.
Okay.
But you can see there, and there's even more, further out than that.
Right.
So
this is sort of
and then this is just a side view of the same thing, kind of giving you a little perspective, I guess, on where that is right now, that YR4 comet.
Okay, this slide we already talked about, the possible impact with the moon. And then this last image
and
here.
then this is the European Space Agency is proposing to put in orbit, actually, you can see it kind of in front of the Earth at what's called a Lagrange point, where it can stay kind of stationary, and it can look just close to the sun to find things, because this asteroid came at us from the direction of the sun, which obviously makes it hard to see things. And it was kind of a surprise. And then I forget what year it was now, Trebelinks out in Russia, where this big old thing came in and blew up in the sky.
Right.
That also came at us right from the sun. So that was a big surprise.
That's frightening.
That is frightening. Give the timing, if the timing was a little different, or if that was a little bit bigger, if it actually hit the ground, that would be tough. This
YR4, do we know the size of it? I mean, the size of a baseball, or the size of a Volkswagen?
No, we're talking about the size of I think like a 10-story building, something about that.
So it's a good size.
So it's a decent size, although in astronomical terms, that is still pretty tiny.
Right.
If it hits the moon, it's going to leave a crater, maybe 1.5 miles wide. It'll kick up a lot of dust or rock and debris that will go into orbit. That will threaten things we have in orbit around
satellites, everything.
Satellites, exactly.
International Space Station. There's human beings up there.
If it comes to the Earth, it will threaten all of those things. Yes.
So if it impacts the moon, the moon controls a lot of things here on Earth.
Right.
Could it get the moon out of orbit a little bit?
The moon's not going to barely feel that, because 150 feet compared to the size of the moon. The moon's a quarter of the size of the Earth.
Right. Okay.
The difference in mass is just phenomenal. The moon is barely going to feel that.
Like you and I getting a mosquito bite. Annoying, but
we don't feel that mosquito land on us.
Right. Interesting.
So, Yeah.
We are up on our second commercial break. We've got more space talk when we come back, so stay right there.
This is 22 News in Focus with Patrick Berry. This is 22 News in Focus with Patrick Berry.
Welcome back, everyone, to today's edition of In Focus. Today, we're having a little bit of conversation about what's happening out in space. Kevin Kopchynski, the STEM curator at the Springfield Museums, joins me across the desk today. We were talking a moment ago about an asteroid, called YR4, and it's been in the news about possible impact with Earth. But the scientists, you and others in your world, have determined that the impact with Earth is virtually non-existent.
Yes, correct.
But the moon is still a question mark.
Yes.
It'll circle back in 2028. You'll get a better beat on it and better data and so forth. But there was another item that's zooming through our universe and our nearby universe. And that is something called 3i Atlas. Kevin, explain what 3i Atlas is.
And coming through the universe is a good example, because that came not from outside of our solar system. That is an object that was out there in interstellar space and just happened to come our way. Okay,
so this is an item that we don't know its origin.
So we don't know its origin. They've traced back. I saw one report of where they've traced back to where, other stars that may have been near in the distant past. But no, there's no way of knowing where it came from.
Okay. So, and there's been a lot of talk that it's a spaceship.
Yeah. So so our earlier conversation about what makes a comet really comes into play here.
Okay.
Because basically this thing is a comet. It's doing all the things that I described.
But it's not unreasonable to say that it could be. There's like YR4 hitting the Earth, there's still a slight chance, right, that it could be a spaceship.
So I think at this point on this object, that's the observations I think have pretty much ruled that out.
Okay.
And the one thing to keep in mind, a lot of some of the UFO folks point about how unusual it is. The thing is, there's no such thing as a usual comet.
Good point. You can, based on historical data, you can kind of predict, but it's like the weather.
Yeah.
You can kind of predict what may happen, but things can change.
Yes. Yeah. Yeah. I mean, they've been likened to cats. They both have a tail and they both do whatever the heck they want.
I love that. That's fantastic.
So, and there are some things that it's come from outside of our solar system. It's moving at a speed that the sun's gravity cannot capture it. So it's moving much faster than other objects, than a comet that that is in orbit around the sun. This one is not in orbit. This one is just coming by.
It's just zooming by. So, and at such a velocity,
that
the sun's gravitational pull is not affecting it.
Cannot. Well, the pull is affecting it because it kind of brought it in, and it's coming in. It's swooping. It's going to be outside the orbit of Mars, but still it's kind of swooping in, but then it curves out and it leaves.
And it goes.
Yeah.
Okay.
Yeah.
So you sent me some images and stuff that I want to pull up here.
So go to a nice rogues gallery. So this video shows its trajectory. Here it comes from wherever it's coming in, it gets kind of close to the, its closest is still outside the orbit of Mars.
Right. What do they call it? The inner solar system?
Yeah.
Or
that's the inner solar system. And that's its closest to Earth, I should mention. That's as close as Earth to Earth as it gets. It got closer to the sun than that. But it's fast enough where it's not going to get captured and it's going to go right back on its way. Wherever.
I'm going to see if I can freeze this. I missed it. Patrick, come on.
I think, there it goes.
There. I keep missing it.
Yeah, I mean, you could see it kind of come in, and that's where it was starting to make its curve.
It kind of arcs a little bit.
So it's making this arc, and that arc is because of the sun.
Okay.
It is.
The gravitational pull, right?
Feeling the gravity of the sun. Much like we do. in a way, we feel the gravity of the sun, but we're moving fast enough, like we on Earth, our Earth, that is,
Right.
not us personally, that the Earth's moving fast enough that it stays where it is in the solar system. It doesn't fall into the sun, but it also doesn't move away.
Okay.
So there's a balance there. So anyway, it's not unreasonable to ask whether something might be a spacecraft. However, once you make observations, it's not likely.
Okay.
It's not likely.
So that begs the
at all.
that begs the additional conversation of alien life.
Sure, what's out there? Right.
Because scientists have proven that 3I Atlas is not a spaceship,
right?
Just based on information that you've been able to observe and calculate.
Mm-hmm.
But it's not to say that there isn't life out there, right?
So this is all. This is always our great question, right? Is it possible that there is some civilization out there that sent some kind of spacecraft? And it's not impossible.
Right.
How likely? That's a whole other question.
And I think we've, as a layperson, you know this better than I, but I think your scientists in your world have determined there is alien life. It could be atoms or micro life.
So
but intelligent life is.
There's a big difference between intelligent life. We have not found any solid evidence of any life beyond the Earth yet.
Right.
Okay. We've come close on Mars, but that's it. And so, and when we're talking about spaceships, we're talking about intelligent life. Right.
Right.
And one of the, one sort of tool to try to get a handle on this, which turns out you don't have much of a handle, is something called the Drake equation, where the astronomer named Frank Drake was thinking about this question, and he realized, well, there's just a series of steps you have to go through to get to be a civilization. You have to, how often does a star form that can have life on, that's suitable? How many of those have
Goldilocks zone?
Sort of, how many of those have planets? How many of those planets are in the Goldilocks zone? How many of those go on to develop life? How many of those go on to where life develops into, something intelligence, right? And then the real key is once that intelligence gets to the point where it can communicate to space, because he was just looking for communications, how long does that civilization last?
Right.
And that's a real big key. So, I've seen...
It's not impossible.
It's not impossible.
There's no...
But I had, people throw numbers, and the thing is, none of those steps are really well constrained. You can almost put anything into those.
Any variable, right?
Yeah. And so I've seen, credible numbers go in, and, you come out with thousands of civilizations. I've seen credible numbers go in, and there's one.
Right.
Us.
Exactly.
Right. And that also is a serious possibility.
Fascinating. What a great way to end. Kevin, I want to have you come back at a future episode just to talk about the chances of alien life.
That's worth a whole discussion. Our planet is a very special place.
Absolutely. Yeah. Kevin Kopchynski, STEM curator, Springfield Museums. Thank you so very much for joining me today.
Thanks for having me again. It's been great. It's been great.
This is 22 News in Focus with Patrick Berry.